Okay, so we were saying here that whenever we want to compare two plans, okay, we should find which one is better to use. So my strategy is to replace B with A. If I want to, to replace A with B. If I want to replace A with B, I should test the overall balance of incomes and costs if I do this replacement. Now, I should pay attention that if I'm doing the replacement of A by B, I can sell now A. This is why they should give me not only the salvage value of A, I should know if I want to sell it now, what will be the price. So they gave me that I can sell it now at $10,000 while I need $100,000 to buy B. So I can say that the initial investment in overall is 1,000 minus 10,000 is $90,000 now. This is paid now. And since we are doing the net present value, we are taking all cash flows to the present. So we don't have here to divide I by anything. While for the incomes and costs for each year, we should divide by 1 plus 8 to the power I, where I represent the discount rate. Okay. Now, since we are searching for the ROI will be the value of A for which NPV at year 20 will just be equal to 0. So we were saying that to compare both scenarios, let us see what is the effect of replacing A by B on the income and on the cost. For the income, we should compare the productivity of the two systems. Okay, so and plus also we can look at the reduction of costs that we have, because the reduction of cost is also an income. So when we replace machine A by B, the enhancement is due first to the increase in the productivity, but also it's due also to the reduce in cost. So first, to look at the enhancement in productivity, so we can calculate delta RI, which is the income per year from machine B minus the income per year from machine A. If we compare the productivity of the two machines, we can see that we have an increase in productivity from 200 parts per week to 500 parts per week. This is why we can say that since per week the increase is 300 parts, so we have for each week 300 additional parts. In order to know for a complete year what is the increase in income, we should multiply, of course, by the number of weeks. Okay, so let us consider, for each month, we'll consider 4 weeks, and 4 times 12 will give us the total number of week per year, which is of working week, which is 48. Okay, and times the cost per piece. So for each piece, you can sell it at $5. This will give you per year what is the increase in your income. Now, on the other hand, for the cost, here we'll have a reduction in cost. So in overall, in your balance here, you will have in total plus delta RI, okay, and minus delta cost. But here the delta cost is negative. That's why you'll have here two numbers to add, because you are increasing the productivity and you are reducing the cost, which will give an advantage for plan B over plan for using machine A over using machine for using machine B over machine A. Okay, but of course we should pay attention that the investment is very high. So we need to first we need to have a total income to be able to balance the investment and to gain more also. Okay, taking of course into account the time value of money. This is why we are dividing by 1 plus a to the power I. So now if we continue with delta cost, we have first, as we said, we were discussing that the maintenance cost is reduced by $100 per month because it was $200 and now it's $100 per month. So we should do minus $100 per month, and don't forget to multiply by the number of months, so times 12. And also plus we are reducing the cost of the worker, so here you should do also minus 500. Okay, so now once you obtain this, you can replace in your equation. Now for the salvage value, of course we divide by 1 plus 8 to the power n. Here, because we are, please pay attention, only the salvage value is included in the ROI analysis. Okay, because if you don't have the salvage value is only applicable at the end of lifetime. This is why in this plan, if you replace A by B, you will not use the salvage value of A. Instead, you will use the value that if you sell it now, because if you don't need it, you will sell it now and you will replace it then by B. Okay, so what we can do then is to replace now for B, the salvage value is 5,000. And this will allow us to calculate the value of the ROI. Okay, here in this problem, we don't have, if you want, in the previous problem I gave you, we practiced on if we have several variation in maintenance cost, if you have variation in productivity, what to do. As I can tell you, for year one, let's say the production is 500 parts per week. For for the coming 5 years after, it will be reduced. They can give you variable production or variable maintenance. You know how to deal with this from the previous example we did together. Okay, so all you have to do then is to divide this term into several parts, and how to deal with it mathematically. We also tackled this in the previous problem, but I just wanted to introduce for you here this idea and how sometimes reducing the costs will be for you is an income. Okay, so now all we have to do is to do some trial and error, okay, to find the corresponding ROI. In the exam, you can first use the calculator to have an idea about the range, okay, but please, after having an idea, you should perform some iteration to show you how you can do it without having to apply any without use of a complex calculator. You can do it because you can do some iterations by replacing this term by the geometric expansion that is provided for you. The geometric expansion, I will give it for you in the exam. Okay, so you just have to apply formulas and now and know how to find the ROI. Now, who can tell me in general a high value of the ROI is encouraging or not? Yani if you have a high ROI value, you will say I will go for this plan, or I say no, it's not worth of going through it. How you decide from the ROI what to do? Who can tell me for the ROI, it's good to have it high or small? Okay, let us do some analysis together. What do we mean by high ROI? Okay, when you have a high ROI, this means that in general for the ROI, you can say that if the discount rate is smaller than the ROI, then the project will have a net present value that is positive. So if A larger than smaller than ROI, NPV for year N is positive. Why you can say this? Because in general, smaller is A, okay? Higher is the confidence in future. So higher will be your savings. So whenever you find the ROI, if you want, you can say that any value of A below the ROI will give me a positive net present value. And of course, to be on the safe side, as we have seen in the course material, we do not just take NPVN to be larger than 0. We use the CER method. We say to be on the safe side, the capital enrichment rate should be larger than 30%. And the capital enrichment rate is NPV at year end over the initial investment, which is here if you want $90,000. So you should do NPV over I should be larger than 0.3. If this is the case, then you can consider your project profitable. If not, the project is not profitable. But if we just want to rely on the value of ROI to get an idea about if my project is good to go through or not, we can say that having a large ROI is very good. Why? Because let's say you have ROI 20%. This means that any value below 20% will give you NPVN larger than 0. So you expect then if you use a 5% or 10%, which is a conventional value, you have large value of NPVN, and you probably will be close to, if you want, the CER that you need, or higher than 0.3. So you can investigate this. Depending on the value of A, you can replace in calculation to get the percentage of enhancement, but you will be sure that you will gain. Okay, so we can say that a large value of ROI is encouraging because it will increase the interval of discount rates we can work with. On the other hand, for example, let's say the ROI is 5%. This is very bad because to have a positive balance, you should be below 5%. You should be very confident. If you have small risk factors, or if anything changed, if you want, that was unexpected, you will lose a lot. Okay, so this is why having high ROI is essential to proceed with your plan. Okay, while if ROI is relatively small, you can say I still have a lot of risks that were not taken into consideration. So, and probably I might have fluctuation in the economy of the country, or I can have like for example coronavirus, which if you want will impose a lot of off days. So this will lead to decrease in productivity. So in case we don't have a large margin of savings, then any small risk will be very critical for us. Okay. Any question on this problem? Now, can you tell me, if I want to find the payback period, what should I do? What will change in my equation if I want to find the payback period?
Just miss, I have a question.
Yes.
I wrote it on the chat.
Yes, I will check it, yeah. Okay. If we just have the salvage value of machine A after 20 years and not its current salvage value, can we subtract the future value of both machines and put it equal to 0, then get the ROI by trial and error? Look, no, the idea is, you mean you want to project to future? But here the idea is that, no, I will tell you why no. Because in general, the salvage value, okay, is the value of the machine when you cannot use it anymore. Machine A is still productive. You can use it, you can still use it, but because you are bringing a new machine, okay, you don't need it anymore, but you will not keep it with you. You will sell it because its value now is much larger, not only because of time, but because of the productivity. It's still productive, so you can sell it at a much larger price than its salvage value. So we should give you this, okay? And if we don't give it, then you can assume that you cannot, you should keep it, you cannot sell it, you will not then include its price in the analysis.
Okay, thank you.
Okay, welcome. Let me check if anyone, okay. Now, concerning the payback period. Okay, what can we do? Who can tell me if we want to do the calculation for the payback period, what will change in our equation? We did the whole analysis. What will just change? If I write again the equation, okay, this is my equation. I just want to modify it now to calculate the payback period. What is the definition of payback period? It's the time needed, okay, to have just a balance of 0. So you calculated the ROI in previous question. Let us say we have the ROI. Now I can give you a discount rate value. Let us say A, for example, is 2%. And from your calculation of ROI, for example, let's say A, 2% is smaller than the ROI. So you can expect, because A is smaller than the ROI, that of course I have a profit here. So now in my equation, what will change? I will put in red the changes. First, A is not is now known. It's not an unknown. Now I set it equal to 2%. Okay. Now for the salvage value of machine B, I will subtract it, because now I am not at the end of lifetime. I am during the lifetime. I'm doing the analysis during the lifetime. And now I should solve for the payback period. I should solve for N. So what will change in my formula is that NPV at year N is equal to 0. Okay. I have the investment. I keep it as it is. Just here, I do summation from I to N. Of course, this term will remain the same. Just I replace A by 2%. So the only unknown in this equation will be N, and I can solve for N. Okay. Any question on this? Okay, thank you, guys. If you have any question, don't hesitate to send me your questions by WhatsApp anytime. Okay. Good luck for your exam. Bye-bye.
Doctor,
Yes.